So today we're going to be talking about coordinate geometry, which is basically about graphs and lines. So coordinate geometry. David, do you want to start with like the terms and definitions?
Okay, yeah. So you probably did some graphs while you guys are in like grade 9, grade 8, but we have a basic graph, which is called a Cartesian plane. So it's essentially just two lines, and then that's our Cartesian plane. And on here, we have the x-axis and the y-axis. So the horizontal line is the x-axis, and the vertical line is the y-axis. And then it's split into four quadrants. So the top right one is called quadrant 1, and then goes into a counterclockwise motion, and it goes quadrant 2, and then quadrant 3, and quadrant 4. So when we write quadrants, we don't usually write it as numbers, but we write it as Roman numerals. No idea why, but it's just like that. And then in the center of the graph where the two lines combine, that is the origin, essentially 0, 0. And we represent a coordinate on the plane as a pair of numbers. So x comma y, that will be how we represent it.
Yeah, so for the quadrant 1, both x and y are positive. So plus plus, like what Alex said. For quadrant 2, the x coordinate is negative and the y coordinate is positive. So negative plus, yeah. Good job, Alex. For quadrant 3, both are negative. So negative, negative. And for quadrant 4, we have positive, negative. And so I'm sure you guys all graphed points before, but just as a reminder, when we have a Cartesian plane, let's say 1, 2, 3, 4. 1, 2, 3, 4. If we have a point right here, we'll first write down the x coordinate, which is 2. After that, we'll write our y coordinate, which is 3. So that is how we label a point. And this goes for other quadrants as well. So for example, if we have a point right here, then we first label the x coordinate, which is 3. Then we label the y coordinate, which is negative 2. Okay. Now we're gonna practice finding the distance between 2 points.
Yeah, okay. So when we're finding a distance between 2 points, a pair of points like 0, 0 and 1, 0 is pretty easy to find because they're essentially on the same line. So you could just count how many points there are away. However, if we have something like 1, 1 and 5, 4, that's not going to be that easy. So what we can use is that we can use a Pythagorean theorem. So when we have 2 points, so for example, if you have something at 1, 1 and 5, 4,
5, 4, and 1, 1.
yes, we can draw a line between them, and then we can kind of form a triangle. And then we can form a triangle based off of that. And the base of the triangle would be the difference in x between the 2 points, and the height of the triangle would be the difference in y between the 2 points. And then what we can do is that we could just use simple Pythagorean theorem and just find the hypotenuse. So in this case, 3 squared plus 4 squared, and we square root that, and that gives us a hypotenuse, which is the distance.
Yeah. So as a
So,
generalized, oh, sorry.
oh no, you can go.
Okay, so as a generalized formula, we tend to make the first point x1 comma y1, and we make the second point x2 comma y2. So as a generalized formula to finding the distance between 2 points, we write d x, sorry, d point 1 to point 2 is equal to, using Pythagorean's formula, x2 minus x1 squared plus y2 minus y1 squared. And it doesn't matter which of these goes first, because when you square them, they're going to end up the same. But that's just the generalized formula.
Yeah, so we can do a simple example. So we could have 0.1, which is 4, 8. Oh,
4, 8.
yeah, it might not be that easy to draw.
Yeah. Wow, this is taking a long time to draw. 2, 3. Okay, 4, 8.
And 7, 6. So you're gonna have to extend the x-axis a little bit.
That's fine.
Oh boy. Yeah, and we can find the distance between them. So in this case, we could just call 4, 8 or 0.1 just x1, y1. So we could put it into the form. Actually, yeah. And then 7, 6 will be x2, y2.
So x1, y1.
So we can plug it into the formula. We get 7 minus 4 squared and 6 minus 8 squared.
Yeah. So if we form a triangle, then this side will be 2 and this will be 3. So like David said, when we plug it into the formula, we get distance between 4, 8 and 7, 6 is 7 minus 4 squared plus 6 minus 4 squared, which gives us
Kevin, it's 6 minus 8, but
oh,
it
wait,
still
sorry.
works.
Yeah, it still works, but coincidence. Okay. What is this, like 9 plus 4?
Yes.
Okay.
Square root of 13. Not a nice distance, but it's still a distance.
Yes.
Okay, should we move on to midpoint?
I think we should give them a couple of examples.
Oh yeah, okay. Let's just give them we could have a point 110. And negative 9, 6. Yeah, so if you guys got the distance between those 2 points, you could put it in chat.
Square root of 80. Let's see. I think I got something different.
Yeah, same. It's not a nice number.
Yeah.
think it's the square root of 164. 116.
Yeah, 116. I got that as well.
Yeah. So 116. Good job. So what we would do is plug in the x1, y1, x2, y2, and we get negative 9 minus 1 squared plus 6 minus 10 squared, which is 116. The square root of 116. And I think
we
this
could-
is
Yeah, 2 root 29, I think.
yeah, 229.
Oh, yeah. Be careful of the
Oh, okay.
signs.
Yeah. Okay. Should we do one more or
Yeah, we can do another one.
okay.
We can do a 4. Yeah. I'll have the point 4, 3 and 8, 6.
Uh, 5.
Yes. Yep, that's correct.
Oh yeah. Yeah. Good job. No, I think you did good. Good job.
Yeah.
Oh yeah, he definitely. Yeah. Okay. So when we poke in the points, we see 8 minus 4 squared plus 6 minus 3 squared, which is square root of 25, which is 5. All right. Awesome.
Yeah, so we should move on to midpoint. So when we think of a midpoint, it's when we have 2 points on the Cartesian plane. So like we could just have some random coordinates like 1, 1 and 2.
Let's lay
Yeah.
the distance between x and y halfway. It's like it like if like the midpoint would be like in halfway, so the x would be half of the like distance as well.
Yeah, it's the average between the x and the average between the y. So
Yeah.
we can just draw a random 2 points. Doesn't have to be anywhere. It's just kind of an example.
Oh, okay. So here and here.
Yeah, and then we draw a line between the 2 points. We can think of the midpoint as like the point in the center of that line. So the halfway distance, that would be the midpoint between the 2 points. So as Alex said, to figure out the midpoint, we would just have to calculate the average between the 2 x's and the average between the 2 y's. And those 2 numbers will be the midpoint.
That's why. Okay. So the coordinate of the midpoint will be x1 plus x2 over 2, because that's the average, and y1 plus y2 over 2. That's the average for the y coordinate.
Yeah, so we can do a simple example with this. So if we have the 2 points, 3, 4, yeah, I don't think you have to draw like the ticks. I think we just label it.
Oh, okay. Sure.
Yeah, and then we have 7, 6.
I'll draw for this one.
Oh, okay.
4, 5, 6, 7.
And then we can try to find the midpoint between those. So the midpoint will be the average is the x coordinates, which will be 3 plus 7 divided by 2, which is 5.
Sorry, I'm a bit slow.
Oh, it's fine. Yeah, 3
3.
plus 7 divided by 2, which is 5. And then we have 4 plus 6 divided by 2, which is also 5. So the midpoint will be at 5, 5.
Yeah, and you can also kind of just look at this and think about it intuitively, because this is around 5, and the y coordinate is also around 5. So, I mean, another way you could do it is just by looking at it and, you know, doing it by your eyes, I guess.
Yeah, if you have like a bunch of graph paper, you can definitely do this.
Yeah.
let's give them an example, like
Right,
question
sure.
2. Yeah, so we can have the 2 points 3, -2. And 4, 2. Yes, that's correct, Edward. It's 3/2 and 0. So we have 3 plus 4 divided by 2 and -2 plus 2, which is just 0 divided by 2. So we end up with 7/2 or 3.5 and 0.
Should we like do one more?
Yeah, we can do one more. Do you have an example in mind?
I can try making one.
Yeah, you could just think of random points and I think it will just work.
Yeah. Okay. 0, 0. Yeah. Good job.
Yes.
And the reason that the midpoint is 0, 0 is because it's symmetrical around the origin. So when we draw this out, we see that one point is here and one point is here. So they're symmetrical about the origin. That's why the midpoint is 0, 0. Okay. Moving on.
Yes. So should we move on to slope?
Yeah.
Okay. Yeah. So a slope is basically a characteristic of a line. So a line between 2 points, and it basically just measures how steep that line is. So for example, if we just have a horizontal line, the slope will be 0 because it doesn't go up or down. So it's not even steep. And we can always think of a slope as the rise over run. Yeah, the slope of a horizontal line is 0. And if it's a vertical line, it's just undefined. You'll see later when we do the calculations for how to find slope. Yeah, so slope is defined as a rise over run. So you could think of it as every movement in the x direction, we go up by, it goes up vertically by the slope. So we can have a line with a slope of 1, where every time you move in the x-axis, you move the same amount in the y-axis. So have a slope 1. So yeah, that
Wait.
works also. Can't select
1
it.
second. There we go.
Yeah. So the points on this line will be values like 1, 1, 2, 2, 3, 3. Those will be all on the line because for every time we add 1 to the x-axis, we add 1 to the y-axis as well. And if there's a slope that's smaller than 1, so for example, when we have a slope like 0.5, it's just not as steep.
Oh yeah. By the way, the symbol for slope is m.
Yeah, small m.
Yeah. So David, you're saying like a slope less than 1?
Yeah, like 0.5.
Yeah.
And if we have a negative slope, then when we think of it where it's going from left to right, it's going downwards. So if we have something like -1, it's very high in the top left and goes low at the top on the bottom right. So that will be a negative slope. And it's
I
just
think we should. Oh, sorry. I think like
Yeah.
we should talk about like what rise over run really means, like on a graph.
Oh yeah, good idea. Okay, let's just have 2 points. We can have 2, 1, and 1, 0. Oh yeah, or we
Two,
can use
1, and 1, 0.
yeah,
We could just use like on this one.
yeah, that also works. We could call the bottom one 1, 1, and then the top one 5, 5. Yeah, so what we mean by rise over run is how much it moves in the y coordinate divided by how much it moves in the x coordinate. So in this case, it will be the x2 minus x1, which would be the run, and then y2 minus y1, which would be the rise. So if we want to find the slope of this line, pretend we didn't know that the slope is 1, what we would do is that we would do 5 subtract 1 divided by 5 subtract run. Yeah, 5 subtract 1.
Yeah.
And then when we divide those two numbers, it would give us a slope.
Yeah. So
And this is-
basically, oh, sorry, you can go.
Oh, no, you can you
No,
can
it's
go.
okay. You can go. It's okay.
Oh, I was going to talk about something else, but I think you're going to talk about this.
Oh, okay. Yeah.
Yeah, I can go after.
So, all right. So a rise is basically the difference between the two y coordinate. Now, in the case of a slope, the sign does matter. So whether it's positive or negative, you have to keep track of the sign because we're not squaring it, unlike the distance. So the rise is the difference between two y coordinate, and the run is the difference between two x coordinate. Now, if m is positive, the line will be going up, and if m is negative, the line will be going down. So, okay.
Yeah, so this is also the reason why a vertical line has undefined slope. Because if we do the calculations for a vertical line, like the 2 points 5, 0 and 1, 0.
Wait, you mean like 0, 5 and 0, 1?
Oh yeah, whoops. Sorry about that. 0, 5 and 0, 1. Yeah, what we can see is that we have the rise, which makes sense. It's 5 subtract 1. And then we have the run, which is 0 subtract 0. But then we realize that we can't divide by 0, so we can't find the slope of it. So it's undefined. Yeah.
Or you
So
could
it's-
just write infinity. But
Yeah, that also works, but I think teachers will prefer undefined.
yeah.
Should we do another example of a slope?
Sure.
We can have like -4, 3.
Wait, is this for us to do or for them to try?
What do you feel like?
We can do one more.
Okay.
Like us.
Yeah, we could have the 2 points -4, 3. And 1, -3. Yep. Okay, so we can do the rise over run. So in this case, rise, it's 3 subtract -3.
Oops. Let me just draw out the rise so it's more clear.
Yes. So 3 subtract -3 or -3 subtract -3, that also works. Wait, yeah, -6. And then what we do is we do, oh, I think it works either way.
Oh yeah, okay. Oh wait, no, it has to be the second point minus the first point because the sign matters. So -3 minus 3.
Well,
Yeah, because then you'll have a rise of 6, which is not the case.
I think you just got to do it in the same order. So like 0.1 subtract 0.2 and 0.1 subtract 0.2.
Oh
If
yeah,
you get
that,
what I mean. Yeah.
yeah, that works, but I feel like just always go with the second point minus the first point, I think.
Okay, yeah. Better idea. And then we do 1 subtract -4 for the run. Get 5, and then we could do rise over run, which is -6 over 5. So that will be our slope.
Oh yeah, for slope, it's always good to write it in a fraction form. Don't turn into decimal, please.
Yes, it's going to be real useful if you're doing equations later.
Yeah. Okay, so does that kind of make sense? Does anyone have questions? All right, well, take silence as a no.
Okay, yeah, we should give them some examples.
All right, 2 points.
Yeah, so we can have like the point 1, which is 0, 4. And then we can have another one, which is 3, -2. And if you got the slope, you can put it in chat.
Oh, okay, I can try to draw it out and write down the formula again.
Yeah,
It's just the no. It's like this, like the change in y over the change in x. You set one as start. You set one as stop, and the start one's x mine, and yeah, the start one's like. But it's really you choose it. Who subtracts who is up? That's up to you. But don't get them mixed up.
Yeah, so what you said is absolutely correct. I think for the sake of simplicity, we always do 0.2 minus 0.1, just so the run is positive. So like for this question, we have 0, 4 and 3, -2. So we always want to do y2 minus y1 over x2 minus x1 for the slope.
Edward,
Let's see.
you're close, but I think you did run over rise
Yeah.
or
So
something.
y
Yeah.
over x.
That's incorrect.
Yeah, Alex, you've done it correct. Good job. Edward, yeah. So it's the second point minus the first point, not equation.
You gotta remember it's rise over run anyway.
Yeah.
Not run over rise.
So like rise over run.
Yeah.
Oh yeah. So Edward, you've done it correct, but instead of equation, it's a point. So just reword it to second point minus the first point.
There isn't really which point minus which point. You can do like the midpoint method where you label like x1 and x2, no, x1 and y1 and x2 and y2, and then you just have to do 2 minus 1 and 2 minus 1.
Yeah.
Yeah.
So okay. So for the sake of simplicity, we'll just say the first point is 0.1 and the second point is 0.2. And what we do is just find what this is, find what this is, and then divide them by each other. Edward, yeah, so it's left to right. Yeah. Okay, so do you want to explain it or?
I think you can.
Okay, sure.
Yeah.
So M is rise over run. The rise is y2 minus y1, which is -2 minus 4. So this would be -6. The run would be x2 minus x1. So that would be 3 minus 0. So this is 0. I mean, sorry, this will be 3. So the answer will be -6/3, which is -2.
And yeah,
you
we
wanna
should
give
do another
another?
example.
Yeah.
Yeah, just to clear up the confusion a little bit. So we can have the origin as one of the points, and then we could do 4, 7. So this one's kind of an easy one. Oh, Edward, I think he did. I think he did run over Rise again.
Yeah. Yeah, 7
Yes.
over 4. Okay, so rise over run. The rise would be 7 minus 0, which is 7. And the run would be 4 minus 0, which would be 4. So m is 7 over 4. Rise over run. Yeah, it's rise over run. And honestly, I will suggest that for the point 1 is the left point, and point 2 is the right point. I think that's a better strategy. So just label your left point P1 and your right point P2. Okay, awesome. So should we move on to x-y intercepts?
Yeah, we can.
Okay.
Okay, actually, do you guys understand this now? You can just type in chat. Yes. Imagine you're running like horizontally, so that will be the x. Yes.
Yeah. Yeah, good job.
Okay, yes, that's great. Okay, let's move on. So next thing we're going to talk about is x and y intercepts. So the x and y intercept is basically just 2 points that correspond to when the line touches the x-axis and the y-axis. So for example, we could just have a random line. How did I get negative though? Oh, you had a negative in the numerator and the denominator, so you could just cancel those out and it'll become positive.
Yeah. So I think what you did is you did P1 minus P2. Yeah, okay, Edward, so you did P1 minus P2, so y1 minus y2 over x1 minus x2. But what we did is y2 minus y1 over x2 over x1. But both give you the same result. Yeah. Right point minus left point.
Okay, hopefully no more confusion.
Yes.
Okay, yeah, so we can just, yeah, when the line touches the x-axis and the y-axis. Or the y-axis, actually.
Or y-axis.
Yeah, so we can just draw a random line. Doesn't have to have exact coordinates. Yeah. So in this case, the y-intercept would be when the line hits the y-axis, so the red point, that'll be the y-intercept. And when it touches the x-axis, that will be called the x-intercept. So when we have a y-intercept, it's always 0, y, and then when we have the x-intercept, it's always x, 0, yes. Yeah, okay, so we can draw a line with some points. And then
Sure.
draw.
Oops, do you wanna like an equation?
Should we though?
Depends on you.
We haven't talked about that yet, but
Oh, that's right. That's true.
yeah. Yeah, but we can have an example line. So, for example, made up numbers, but this line would have like -1, 0 as an x-intercept if we're like estimating where the x-intercept is, and it will have 0, 1 as the y-intercept.
So the x-intercept would be -1, 0. And the y-intercept would be 0, 1.
Yeah. So having one of the numbers as a 0 is kind of a nice property later. Wait, so if the line intercepted the origin, then the x and y intercept would be at the same place, right?
Yeah, it's
Yeah.
both 0, 0.
Pretty much just any
That's a-
time it intersects the axis.
Yeah, that's a great question. So like, for example, when we have a line that goes like this, the x-intercept would be 0, 0, and the y-intercept would also be 0, 0.
Oh, what can you use intercepts for? You can use it to solve equations, like which we're gonna talk about later. But when you're like missing a number in an equation, you can always use the property that one of the numbers is 0 to solve it.
Yeah. Or you can use it for something like real life application. So for example, if we have an airplane, I won't get into too much detail, but if we have an airplane that starts at takeoff and then lands at some point over here, then the first x-intercept is the time in which the airplane takes off, and this intercept is when the airplane touches ground, and the y-intercept is the highest point that an airplane can fly. So like, they both have to do with zeros. I guess that's a way to put it.
Yeah, it's gonna be quite important when you guys learn quadratic equations later.
Oh yeah, definitely.
Yeah. Okay. So we should actually talk about the equation of a line.
Oh wait, should we just like give them some examples?
I
Let
don't
them
know if
try
we
out?
can do examples.
Well, we can let them figure out which one is the accent and which one's the line.
Yeah, totally. Think that'll work.
Alright, 2 points. Or we could actually just name a bunch of points. So like, I don't know, 5, 4, 3, 2, 0, 4, 3, 0. Which of the following could be the x-intercept, and which of the following could be the y-intercept? Zero, 4 as x and 3, 0 as y. You're close. You're definitely on the right track, but it's actually flipped. X is number 3. Edward, for the first 2 points, they're actually not x-intercept nor y-intercept. I just put them in to trick you guys. But yeah, so the x-intercept would be 3, 0. 0, because when you draw them out on the graph, 3, 0 is like right here. Wait, David, am I right? Or
Yeah, you'll be right.
okay, just so I'm not making anything wrong. The y-int is 0, 4. Because when we draw them on the graph, this would be 0, 4.
Yeah, so it's kind of confusing, but you kind of think of the opposite coordinate. So when you think of x coordinate, you're looking for the y value to be 0.
Oh, yeah, that's a good way to put it. So the x-intercept is when the y coordinate is 0, and when the And for y-intercept is when the x-coordinate is 0.
Yeah,
Okay,
and
should we do like another one?
do you want to?
I think we have time.
Yeah, okay, we can do another one. Like
Okay.
the same format as this, or do you have another idea?
I think the same format works well.
Okay.
All right, do you want to give some numbers?
We could have 0, 0, and then 4, 0, and then 5, 4, and then 3, 1.
That's all?
Yeah.
Okay.
It's gonna be okay. Put all the coordinates you think is the x-intercept in the first one, and all the coordinates that you think is a y-intercept in the second one.
What's x int and y int again?
It's just shorthand for intercept.
Yeah.
So when the line touches the x-axis and when it touches the y-axis.
One is all and 2 is for x. Yes. Great
Yes. Got that. All correct.
job. All right, should we like explain how?
Yeah,
The answer.
okay. So for the first coordinate, 0, 0, we kind of talked about this earlier in the class. It's a point where the x-intercept and y-intercept can be crossed by the line. So it goes in both. And then when we see 4, 0, we got to think of the opposite. So in this case, the y is 0, so it's the x-intercept.
Yeah, or you can just they both touch the x-axis.
Yeah, that also works.
Yeah. Okay, do you want to move on?
Yeah, we should move on. Yay, so we're on to equation of a line. Today we're going to talk about linear equations, so it's just a straight line. And the first thing we're going to talk about is a slope-intercept form. So a slope-intercept form is just an equation where if you slap numbers in there and it works, then it will provide you with a line, a straight line. So it goes in the format of y equals mx plus b. And you might have noticed where that m came from when we talked about slope earlier. So the m would be slope. And the b will be the the b will be the y value of the y-intercept. Yeah. So for example, we can have something like y equals to negative 2x plus 3.
Wait, 2x or negative 2?
Negative 2x.
Okay.
I mean, I think both will work. I'm just making it
Yeah.
up right now.
Okay.
Yeah, so this equation would describe a line which has a slope of negative 2 and goes through the point 0, 3. So we can kind of roughly draw it, I guess. So we can first draw where 0, 3 is. And then we can kind of roughly estimate how steep negative 2 is. So
Slope of negative 2, yeah.
Yeah, so that would roughly be what the line looks like. And it like it extends continuously in both directions. So to actually make the line drawing easier, we can actually figure out the x-intercept. So we kind of know already that when we have an x-intercept, the y-coordinate will be 0. So we can kind of use the equation above. We could put y as 0. And then what we can do is that we can use basic algebra, isolate the x. 2x equals 3 and x equals to 1.5. So the x-intercept will be at 1.50. And using this technique, we could also create the equation of a line based on like a few points. So we could have example here. Okay, let's make up some points. We can have like a partial equation. So like y equals to 2x plus b. In this case, we don't know the y-intercept, but we do know a point that is on the line. So for example, we know that 3, 4, that point goes right on top of that line. What we can do is that we could fill in the x and the y. So y will be 4 times 2 times equals 2 times 3, and then plus b. And then again, we could isolate the b. So b equals to -2. So that would be the y-intercept.
And if we plot this, we get a graph that approximately looks like this. And then this point is 3, 4. And this point is 0, -2.
And we can also plot the equation of a horizontal line. So we kind of know already that a horizontal line has a slope of 0. So we can do y equals mx plus b. And since we know that m is equal to 0, we don't really care about the ym. Because m, actually I have no idea why they call m the slope.
It's a Latin word.
Oh, okay. Well, there's your answer, Edward. Yeah. So
Yeah. So slope in Latin is. Wait. I think okay. Someone needs to see asked this in my math class, and the teacher was like, he searched it up. Oh yeah. So sorry, it's French. So in French, slope means monter, or I guess that's how you pronounce it, monte. So this is the slope in French, and that's why we abbreviate it as monte. I never took a French class, so I wouldn't know.
yeah.
David, have you taken French class?
Nope, never. After like junior high, I've just never taken it.
Oh, okay.
Yeah. Okay, so if we have a horizontal line, we know that the slope is 0. So we can just simplify it down equals to y equals 0x plus b, which is just y equals b. And b is just the y-intercept, and a horizontal line will always have a y-intercept. So for this line, we could have like a y-intercept of 2, 0.
Wait, 2, 0? You mean 0, 2?
Oh yeah, whoops, 0, 2. Okay.
Yeah, it's
Yeah,
confusing.
don't be like me and mess up the order because that matters.
Yeah.
Okay,
Y is left 2. That's always.
yeah,
Yep.
y equals 2.
Y is 2.
And then, and if it's a horizontal, you'll say x is 2 or something.
X is 2. Oh yeah, definitely. Yeah, good job. So if we have a line that goes like this, the equation of this would be x equals 2 instead of y equals 2. But that's out of our curriculum, so we won't be talking too much about it.
Yes. You can also think of this a little logically, like no matter what position of x, your y coordinate is always going to be at 2. So you could just write it as y equals 2. Yeah,
Yeah,
negative
so-
5, still 2. Square root of 3, it's still 2. theoretically, if y-intercept is 2, then b is 2.
Yeah, so that's actually the definition of a y-intercept. That's the definition of B, sorry.
Yeah.
B is always the y-intercept. Yep. Okay, so I guess now how do we figure out the equation of a line when we are given 2 points? I think that's a bit harder, but I think this equation will work. So y2 minus y1 is m times x2 minus x1. David, do you want to talk about this? Or like, should we just skip it?
I don't remember this equation.
Oh, you don't? It's just a slope equation.
Yeah, I know, but like, I don't think I've ever used it before.
Oh, yeah, use it when you
Yeah.
have 2 points. I guess we could talk about it since we're pretty much done with this lesson.
Yeah, I think we can.
So what if we're not given the point of a y or x coordinate? What if we're given 2 points such as 3, 4 and -2, -1? So in this case, we would actually use a formula. We would use this formula. And so what we do is firstly label the left point P1 and the right point P2. So y2 is 4 minus -1. And now we have to actually find the slope. David, what's the slope?
Oh,
5/5, so it's 1.
yeah, I think so.
Oh yeah, it's 1. So m is 1 times x2. Wait.
Uh-oh, what is x2?
Wait, no. Okay, wait. What is this equation used for?
I have no idea.
Oh, I think it's okay. So you're given a slope and you're given a point.
Oh, I see.
Wait, but then how would you find the
Wait.
equation between 2 points? Right.
Wait, if you have a slope and a point, then you can just use y equals mx plus b.
Oh yeah, that's true. Well, you don't know what b is though. Oh wait.
Okay, wait.
Okay, wait. Sorry.
This is getting confusing.
Ignore this equation I wrote. Okay, if you're just given 2 points, -2, -1, and 3, 4. Okay. Oh, okay, wait. So we still use this equation. So the first step is to figure out what m is. As we've talked about before, m is 4 minus -1 over 3 minus -2. So it's 5/5, which is just 1. And then what we do is pick out one random point. So either left point or the right point. It doesn't matter which one you use. But we'll just say the left point. So we pick out the left point, which is -2 and -1. And then we use the top equation. So we would actually, okay, this is very confusing, but what we do is plug in this point into x1 and y1. So y minus y1, which is -1, is equal to m times x minus -2. And then we just figure out what this is. So y plus 1 is x plus 2. So y is x plus 1. Yeah. Okay, so yeah, finding the 2 points, finding the equation between 2 points isn't easy. It's pretty tricky. But yeah.
Should we give an example of like
Wait, you want to give an example?
what should we do like a question where we're giving 2 points and we just find the equation for them?
Yeah, sure.
Oh.
No. Okay, we'll do this one. We won't.
Okay, we'll do it together.
Yeah.
Yeah, so we can have 2 points like 4, 5, and 9, -5. So the first thing that we're gonna do is find the slope, because if we have 2 points, we're always just gonna find the slope. So we can do like -5 -5 and 9 -4, which would give us -10/5, which is -2. And then what we're gonna do is that we can kind of just put the slope inside of y = mx plus b. -2x.
Yeah, but the thing is, we don't know what
Uh,
b is, so we can't use that equation.
No, because we know 2 points. We could just put those points inside of the equation and find b.
Oh, okay. So I think this is a
Yeah.
better method then.
Yes.
Okay.
Yeah, mx plus b, so y = -2x plus b. And then since we know that these 2 points are on the line, we could put their y and x coordinates within the equation. So we could put 4, 5 because there's no negative sign, so it's pretty nice. So 5, which is a y, and then equals -2 times 4 plus b, and then we could solve it. So b is equal to 13. -13, is it? Or
Positive.
oh yeah, okay, you switched to b as well. Yeah. So the b is equal to 13. So the entire equation will be y = -2x plus 13.
Okay, yeah. So this is a much better method. There are two methods. I don't know why my teacher taught me the first method instead of the second method. It's weird.
Yeah, I have no idea either.
Yeah, my teacher and your teacher are very different.
Yeah.
But yeah, so okay. Just use David's method. Plug it into y = mx plus b, figure out what b is, and then substitute b back in.
Should we do another
Right.
one? Or actually, class is over. Okay.
Yeah, it's already 5. Okay, well, thank you all for coming very much. Hope you guys learned a lot during this lesson, and
Thank
we'll
you.
see you next lesson.
Goodbye. See you later.
See ya.
Okay, bye.